that we are recording with Fathom everyone. So today we're going over Terraform locals and variables and then what their differences are, and then we're going to get some reps on deploying some more AWS infrastructure via Terraform. Little intro. So variables and locals in Terraform serve different needs, but can feel similar at first. Variables let you configure values that might change between environments or between users. Locals, on the other hand, let you define helper values that don't need to be exposed to whoever is consuming your configuration. They both live within your code and can be used to keep your configs flexible and readable. So let's see how this works. So the biggest thing between locals and variables, right, is variables you can change that value, right? So say you're defining locals, those are going to be something that's not going to change, like ever. But variables, that's something that you can change, or say the next person that's going to deploy that same code, they might want to change some certain variables in there. So that's like the key difference. Locals you don't change, variables you do. Pretty much just cover that. They both improve readability, modularity, maintainability by preventing you from scattering certain values across multiple files. Variables in Terraform are defined using a variable block, and they can be assigned and run at runtime through files, environment variables, or CLI arguments. So there's a couple different ways to do it, right? So you can define the variable here, right? But you can also change that value when you're applying your Terraform code just via the CLI, right? So you can say, hey, Terraform apply, and then tag that variable, and you can give that a new value, and that will override the variable value that you already assigned. What I like to typically do is have like an entire separate variable file, which will make more sense like once we get into the lab. That way you have all your variables right there, and you can change the values all kind of in one place. So for you're going into a deployment, you can just go ahead and change whatever you need to, and then go from there. It's a good way to keep things nice and organized. You typically use variables to pass dynamic values like regions, AMI IDs, instance sizes, so your configs can adapt to different situations. You don't want to hard code these in multiple places. So like something like an AMI ID, right? The ID that every, like say we're using Ubuntu latest, right? That ID changes all the time. So we want to have that as a variable so that we can change that as needed, essentially. This is a little bit of how defining a variable goes. So it's its own code block, and it's variable. You give it a name, right? You have a description, the type, right? If it's going to be just like a number or integer or a string in this case, and this is like the default, which is just the EC2 instance size essentially, or the instance type. Value switching. Variables typically shine when you have configurations that will change based on context or environment. For instance, production might need a larger EC2 type, while dev might need some smaller ones. You can keep the rest of your Terraform code the exact same by just swapping out the variable values. When you have different environments like dev, staging, or production, variables let you toggle key settings without changing your core Terraform code. For instance, dev might use smaller instance sizes, and production might need to use something larger. So that in this case, we have like the environment name, right? And the default name for the environment is just going to be dev. And then in dev, it's going to be using instance type of T2 micro. But let's say, and then in the main.tf, so this is in your variables file, we have two variables, environment and instance type. Of course, we have our providers block, so we're using AWS. It's going to be deployed in the US East 1 region. And then this is our code block. So now we have an AWS instance. We're naming it app server or internal variable is named as app server. It's AMI ID, and then here's the instance type. And we're calling out that variable by doing var dot instance type. So it's going to be var for variable dot, and then whatever we assigned that variable to. So that's instance type in this case. Does that make sense for everyone? And then tags, since we're giving it like a tag, it's going to be the dev environment. So this would be like the interpolation, yeah. It's var dot environment and then app. So this is what the name of that server is going to show up when we do deploy that on AWS. So in this case, it would be dev, dev dot app, since that's what we gave it that name in that environment. We have a configuration here that creates an EC2 with variable switching. We can reuse it without having to create additional resources or edit these existing ones. You can keep everything else the same while deploying a bigger instance for production. So this is where I was saying we can change these variables, not actually in the code, but when we are deploying this code, right? So in this Terraform apply command, say we scratch this out. That's not there. Terraform apply is just going to deploy this one EC2 instance with T2 micro with the name dev app. So that's what we have in here. But with this included in the full command, the dash var equals, we have environment equals production. So we're changing this value of from dev, where's that one? From dev right here to production. Now it's not going to change anything in the code necessarily. It's just going to change in that deployment. And then it's going to deploy with a T2 large instance type instead of the T2 micro. Does that make sense? Just in this one command, that's when we're changing it. So it's not changing it like in the hard-coded settings. It's just in the deployment settings.
So Preston.
Yeah.
So you're saying like you can have a.
Right now we are back to recording. Locals let you define internal expressions that are reused throughout your configs, but that you don't want someone to pass in from the outside. They're like small private utility functions or definitions. So it's essentially the same thing as like a variable, but you can't change them. Like you can't change the local's value through the command line. Nor like you're not going to go in and change these variable either. You can reference these just like variables, but they're internal to your configurations. Locals are like small helper definitions you don't expect anyone to override. They're especially handy for inline concatenations, calculations, or repeated strings that show up all over the place. I have used them in this case. Like say we need multiple EC2 instances, rather than like you can do some built-in functions like for each or count where you need say just deploying the exact same resource just multiple times. But yeah, here's like a good representation. So we just have like it's just like the variables like where we have to have a block for it, and then it's just like name prefix. We are giving it the value of my company app, full app name. It's good for concatenations where we're actually passing in those variables. So the full app name is var.environment, and then with local dot name prefix, and then that would be the full name, whatever we define that name prefix as, or it would be my company app since we already defined name prefix in the locals. So the variable could change, right? But this local dot name prefix wouldn't change. So for the environment up here, since this is the dev environment in that case, if we added this locals block, the app name would then be dev my company app, right? And then using the same prefix for an S3 logging bucket. So you could have the logging bucket name, which would be the name prefix and then dash logging. You can do simple things like that, just by setting this value in the local block. Whenever you need that calculated or repeated value, you just do a local.full app name. Does that make sense to everyone? If you decide to rename My Company app to something else, all references, full app name, login, bucket name, DB identifier update automatically. This saves you from hunting down all the old names in multiple files. So that is like a really good case. So we're deploying multiple instances or different forms of compute, right? We're having different, I guess, just different sources of infrastructure, and everything wants to be the same naming convention. Instead of, if we wanted to change that name, if you just change this portion, right, then it's going to update every single one in the app name, in the bucket name, in the database identifier, rather than having to go through every single code block and changing every name individually. So why not just use variables? If a value never needs to be overridden by another user or environment, it doesn't really need to be a variable. Locals help you keep variables short and your config organized by letting you store strictly internal info separately. If a value doesn't need to be changed by different environments or people, there's no reason to expose it as a variable. For example, if you have a static tag, you can always apply it to resources. That's a perfect candidate for a local. So we've all seen the little tags, right, when we're deploying instances or buckets or databases, right? That's using a local there for the tag name would be like a very good example. You could use a variable for a static tag, but then you might have folks trying to override it by doing, say, something like this. But with locals, like I said earlier, you can't do that. Since locals can't be overridden, you don't expect to need that use case, or if you explicitly want to disallow it, stick with locals. When not to use locals, below is an example for using variables with the AWS region. So say we're deploying in live production, right? We would probably be using more than just one region. So having a local instead of a variable for, say, which region we're going to be using wouldn't be as effective. And then we're expecting that you might deploy to different AWS regions. So region can be changed based on someone's specific environment. If it was a local, nobody could override it without editing the code. A variable is more appropriate because you want that flexibility. Variables and locals both follow Terraform's normal interpolation syntax and get evaluated before resources are created. However, there are some nuances in how and where you can use them, especially when it comes to meta arguments like count or for each. This is what I was talking about earlier. So compilation phases. Variables and locals are evaluated in Terraform's config phase, which merges and processes all .tf files. By the time Terraform reaches the apply phase, these values are already determined. Resources and their meta arguments like for each and count rely on the final evaluated state of any local or variable reference. Where you can't use count or for each. You can't declare a count or for each directly inside locals or variable blocks. So it can't be in your variable block or in the locals block, but say when you have that code block for that resource, that's when you can use the for each or count. This will make more sense to once we get to some examples. Those meta arguments only make sense within resources or modules where Terraform is actually creating something. You can still reference locals or variables inside for each. For example, you can do, say we have a locals and we have this user list, right? We can have a, which one is this using? Each key. So the resource is IAM users. And so we're calling out for each. And then it's using the local.user list. So then it's going to essentially be looping over that. And then the name is going to be each dot key. So it's going to pick out Alice, then Bob, then Charlie. So rather than creating an IAM user for all three and having three different modules for those, right? You don't need to do that. You could just have it essentially loop over those, and then you, I don't know, it's like just a lot more efficient if that makes sense. But the actual for each statement is in the resource, but not the local. So that's like the biggest takeaway here. See how this is in the like resource module, right? And it's not in the locals block nor the variables block. It won't work. Syntax differences. Locals are small definitions that can use interpolation, but they can't directly trigger resource loops. Variables can't declare loops in their definition, but you can pass them into a resource that does the looping. When locals/variables won't work, if you need logic that dynamically generates resources in a way that depends on data discovered during the plan, e.g. listing existing resources in an AWS account, you might need to use data sources or other advanced techniques. Locals and variables can't solve that because they're evaluated before Terraform attempts to read external data. So essentially it's saying it's only going to work inside of the code or inside of that blueprint that you're creating with Terraform. It's not going to reach out to AWS and say, hey, I need to use my built-in functionality to the external resources that are already deployed. In short, locals and variables are used to feed values in your resource blocks. The actual iteration or meta commands like count for each happen in those resources or module blocks, using those local/variable values as inputs. You can't put the loop syntax inside of a local or variable block. Terraform's design only allows those meta arguments within resources or modules. And then a couple tips. So use variables for anything a user or environment might override. Use locals or internal references or computations that should never be changed externally. And then keep variable usage minimal by grouping them logically. That way you won't overwhelm your configuration with too many. All right, guys, I'm going to pause the record. So we have our providers block, right? Which is just, hey, we're using AWS, our region, and then also the version of HashiCorp that we're going to be using. So a lot of the times I'll put this in its own providers file. As long as it's in the same directory, that's all that matters. And then here you can see that we define some variables. So we defined the name, EC2 name, which we gave it, and it's going to be DevOps Learning. And then it's variable. And also notice this syntax, right? Is we have variable and then our quotations, EC2 type, the curly bracket open, tabbed over once, and its default equals t2.micro. So we're just giving like the instance type, right? And then close that curly bracket. So every variable is going to have an open and closed bracket. And then we have our AMI ID. I already changed this. You guys can just find that on AWS within the console. Like when you're creating it or launching an instance, right? You can find that AMI ID for whichever one that you're going to use. And then here's going to be our actual resource module here. So we're doing it, we're launching an AWS instance. Our internal variable, which we could reference this to, is tf.ec2. So we're just, this is the name that the referencing that we're giving it inside of our Terraform. That's not necessarily the name that it will show up on AWS, like the actual console once this is launched. The AMI equals var.ec2 AMI. Since we define that variable, it's going to be using that right there. And then the instance type, same thing, it's var.ec2 type because that's what we defined it as. And that's so it's going to be T2 micro, right? The key name, I'm using my key. So you can just plug in your key once you do this. And then the tags, you can do created by put in your name right there. And it's going to be using var.ec2 name, and see how we have this double quotes and then the money sign. It's kind of like Python, right? If we want to add things to that string, or with what is that called? Concatenation, right? And we can call out that variable, which was right up here, the DevOps learning. So this is going to be called DevOps learning dash server on AWS once we launch this. And then we have our output, which is instance public DNS, description instance public DNS for class main, value equals the AWS instance.tf EC2 public DNS. And then, so if we go here, I already did an init, but I think it might still work. So if we do something like this, Terraform init. Did I spell that wrong? Oh, I did. Terraform init. So it's initializing the back end, and it's already done. So that's what gives us these two files up here. So in this directory that I have, Terraform has been initialized and it's connected with AWS. Let's see, I need to pause the recording here. All right. So we did a Terraform plan. It's kind of like a blueprint, just checking, make sure everything's looking good. And then we can do a Terraform apply. After I run this, I do have a question for you guys. Anyone can answer. What's it going to pop up with after Terraform apply with my current command as is? If you guys don't know, it's okay.
Is it going to be an error?
No,
Okay.
it shouldn't be in there. The plan went through. There's an error. I'm working at the troubleshoot. That's not going to be good. It's going to ask for like a prompt, like for me to do the final approval, which I will do now. So Terraform apply. And then it's going to say enter a value. Do you want to perform these actions? Terraform will perform the actions described above. Only yes will be accepted. So it can't be Y or shorthand. It has to be the full yes word. A way to get around that is by doing Terraform apply and then tac auto tac approve. And then it'll just auto approve it. Now it's going to create our instance. So everything should be there. So now if we go to AWS, we have our DevOps learning server right there. Pretty neat. With all the configurations that we gave it. A couple little things to notice, right? I don't have like a VPC. Sorry, that screen is super bright. I don't have like a VPC specified or anything like that, or subnets, anything like that. So it's just going to automatically go to like your default VPC. But you can create an entire VPC with subnets and all from Terraform, basically from scratch. All right, another little cool thing that we can do here. So say we want to create another file. Let's make a variables file just to keep things looking nice. What we can do here, just copy those over, put those in our variables file, and then now we can just delete those. I think that should be good. Another thing that we could do is we could do providers.tf, and then we can just put.
I don't think you're sharing your screen.
Oh, sorry guys. All right, so I made a variables or var.tf, or you could do variables.tf, right? And I put all the variables in there, and I took them out of my main.tf. So there's no more variables hard coded in here. And then I just created a providers file. We could just take this whole thing and we can just put that in the providers. And then we don't have to have that in here. In something like this, right? I like to keep things nice and organized. So like, hey, like we got to change a couple things, it's all right. If it's the providers block, you can change it there. If it's actual resources, you can change it in your main.tf. If it's something like names or instance type or whatever, like you're going to label those variables as, it's going to be in your variables file. And then as you can like tell, like we're not just going to be typically like production, we're not going to be just launching one instance. We're going to have, say, S3 buckets, or we're going to have multiple instances, different auto scaling groups or load balancing, database servers, right? Or saying we're using something like EKS and we're having EKS clusters deployed. We're having multiple compute resources. There's no need to just have everything on one file. We can divvy these things up so where it makes more sense and it's easier to find. But this will work the exact same as long as it's all within the same directory that has been initialized, or at least subdirectories of the main directory that's been initialized. It will all work. Yeah, that's pretty much it for today.